everyone, if you think back to last week we talked about the power rule. Today we're going to talk about the product and quotient rule. And if you look in your notes from last week, we actually did this problem already. Remember last week we multiplied this in, so we have y equals 5x cubed, and then 5x squared times negative 3 is negative 15x squared. And then we found the derivative of each piece and we got 15x squared minus 30x. And that was our derivative, and that was fine for that problem. It was easy enough to multiply in. Well, also if you think back, we did this example where I said you absolutely cannot find the derivative of the first piece and the derivative of the second piece and multiply them, because that just gives you 10x, and that is not what we got over here for the derivative. So they are not the same. You're not allowed to find the derivative of each piece. So instead, you have to use something called the product rule. And I have two product rules there for you. So the first one just says if you have two functions, to find the derivative of them, you have the first u function and v is your other function. So you keep u the same, you find the derivative of v. You keep v the same, you find the derivative of u. Or in another way, if we have two functions being multiplied together to give you another function, the functions are g of x and h of x. In order to find the derivative of that, we would keep the first function the same, find the derivative of the second function, then find the derivative of the first function, and keep the second function the same. So notice that they're being added. So technically, you can actually switch this whole first piece with this whole second piece. They're interchangeable, so you can put them in either order, however you prefer to do this problem. But I almost always do it in the order that's given right there. So if we look at the same example that we just did up above, 5x squared would be our g of x function, and x minus 3 would be our h of x function. So according to this rule, to find the derivative, I keep g the same, so 5x squared. Then I find the derivative of h, so the derivative of x minus 3 is 1. I add that to, I find the derivative of g, which we know is 10x, and I keep h the same, which is x minus 3. And then I just clean this up a bit, so I have 5x squared plus 10x squared minus 30x. And once again, that would give me the derivative equals 15x squared minus 30x, which is exactly what we got up above. So you can see that the product rule does work, but you have to be careful. There's definitely situations where you have to use the product rule. You cannot always distribute or multiply something out. So prepare yourself. You will have to use the product rule sometimes. So go ahead. I'm going to pause the video for a second. Go ahead and try these two. Go ahead and try these two examples, and I will go ahead and talk my way through them. You pause the video, try them, and then come back and make sure you know what's happening. So if we look at this one, this is our g of x function. This is our h of x function. So the product rule tells us to keep the g function the same, multiply it by the derivative of the h function, and then we're going to add it. Now we find the derivative of the g function, the derivative of x plus 1 is 1, and multiply it by the h function. So we just clean that up a bit. So we have 2x squared plus 2x, and then plus 1x squared plus 1. And of course that means that the derivative will equal 3x squared plus 2x plus 1. And of course, if you wanted to check this, you could FOIL this out and do it with the power rule. But we're going to just use the product rule for today. And on your homework, you have to use the product rule. You cannot multiply it out. So I need you to practice the product rule. All right, let's try this example. We have G and H. So to find the derivative of that, we keep G the same. Find the derivative of H, so 2x minus 3. And then we add that, and we're going to have to find the derivative of G. So the derivative of 3x squared minus 2 is 6x. And then we keep H the same. Now be very careful on this one, because this one's going to require some FOILing. So we have 6x cubed minus 9x squared minus 4x plus 6 plus 6x cubed minus 18x squared plus 24x. So that would be, let's see, we have 6x cubed and another 6x cubed. So 12x cubed. We have negative 2x squared minus 18x squared. So that would be minus 27x squared. We have a negative 4x and a positive 24x. So we know that's 20x plus 6. So we know the derivative equals 12x cubed minus 27x squared plus 20x plus 6. There's our lovely answer to that one. So hopefully you got those two right. If you got those two right, you have the product rule really well. So then we also have the quotient rule, and the quotient rule is for when we divide fractions. We did this last week, kind of. We only had a constant on the bottom, or one value of x on the bottom. So the quotient rule says if we divide 2, we're going to take the bottom, keep it the same, find the derivative of the top, minus, keep the top the same, find the derivative of the bottom, draw a line, and then square the bottom. And this one shows the exact same thing. It's just written in division notation. So you look, that the one in the blue box is the exact same rule. And then this is the little saying that we use in my class. So it's low, D high. So low, D high, low, D high. So D means derivative. So low, derivative of the numerator, minus high, D low. Draw a line and square what's below. So we're going to square what's below. So low D high minus high D low. We draw a line and square what's below. So low D high minus high D low, draw a line and square what's below. So this is the example we did last week. So this is a really simple example, and the reason we only did simple examples last week was because really they were the only thing we could do with what we know. So remember, we just said, well, this is the same thing as 1/3 x squared plus 2/3 x. I can find the derivative of this piece by using the power rule. So the derivative of that would be bring the 2 in front, so 2/3 x, and then plus 2/3. So that's easy derivative. Now let's try that using the quotient rule. So the quotient rule says low, so keep the 3 the same. Low, d high. What's the derivative of the high? 2x plus 2. Minus high, so keep the numerator the same. D low. Well, what's the derivative of 3? The derivative of 3 is 0. It says draw a line and square what's below. So this would be 6x plus 6. Anything times 0 is 0, so all of this is just kind of pure silliness. And then we have draw a line and square the 3, so that's 9. 6/9 is obviously 2/3, and 6/9 is still 2/3. So we got the same answer here using the quotient rule. Now, obviously the quotient rule is a little silly in this problem, but there's plenty of problems where you have to use the quotient rule. So let's look at some of those now. So if you look at this one, because there's multiple things on the bottom, the only thing we could really do here is long division. And let's face it, long division's a pain in the you-know-where. So we don't want to use long division, so we can use the quotient rule. So remember, the quotient rule says low, so low is the bottom, d high, so derivative of the top. So d high means derivative of the top, minus high, d low. Now the derivative of the bottom, d low means derivative of the bottom. Draw a line, well, crooked line, and square what's below. So whatever's on the bottom is just getting put in a square. Now remember, in AP Calculus, we don't have to simplify a ton, but I guarantee on the multiple choice they're never going to leave this, so we are going to need to FOIL this. So we will FOIL this. I'm going to draw my lines. So x squared times 3x squared is 3x to the 4th. X squared times 3 is 3x squared. 1 times 3x squared is 3x squared. And 1 times 3 is 3. Now I'm going to leave that negative a chillin' for a minute, but remember, you're going to have to distribute it. Let's actually put that negative 2x in front, because remember, it's multiplication. I can rearrange that order. So I'm going to make that a negative 2x in front. So it's going to go negative 2x times x cubed, and negative 2x times 3x, and negative 2x times 2. So negative 2x to the 4th, negative 6x squared, and negative 4x. And on the bottom, the best thing to do there is just leave that how it is. If for some reason on the multiple choice they actually simplified that, then go ahead and FOIL it out. But otherwise, leave it like that. Typically, they leave the bottom just with the parentheses and a square. So we know the derivative is the 3x to the 4th minus 2x to the 4th simplifies to 1x to the 4th. We don't have any cubes, but we do have 3x squared plus 3x squared minus 6x squared, so they all cancel. We have negative 4x and positive 3, and we have x squared plus 1 squared. And that's our derivative using the quotient rule. Whoops. Alright, so this one's basically the same thing. Let's set this up together, and then you can use the quotient rule on it. So what does this negative 1 mean as an exponent? Remember, that means that whole thing is going to go to the bottom and become positive. So this is really just a hidden way of putting the quotient rule. So I want you to pause the video and try the quotient rule on this one. I'm going to keep talking, and then if you have trouble with the problem, you can watch the video. If you don't have trouble with the video, you can fast forward and just check the answer. So let's go through this. The derivative would equal low, d high, derivative of the top is 2x, minus high, The derivative of the bottom is negative 3. I'll move that in front in a minute. And then draw a line and square what's below. So we know we have, let's see, 2x times 9 is 18x. Negative 3x times 2x is negative 6x squared. And then I'm going to put the negative 3 in front. Because I'm multiplying, I can multiply in either order. So I'm going to make this a plus 3. And then I'll have 3x squared. And positive 3 times 1 is positive 3. We draw a line. We still have our squared on the bottom. Then we just clean it up some. So we have negative 3x squared plus 18x plus 3, all with 9 minus 3x squared on the bottom. If you did that all on your own and got the right answer, you have the quotient rule mastered. And of course, sometimes they make life a little difficult. So let's look at what would happen if we have a square root involved. So think about the square root rules that we learned last week. And we know the square root is really just another way of writing x to the 1/2. So I have x to the 1/2 minus 1 and x to the 1/2 plus 1. So if I'm going to find the derivative of this, I'm going to do my same thing, but I have a quotient, so I have a division, I have to use a quotient rule. So low d high, oh no, the derivative of the high, remember we moved the 1/2 in front, low d high, and I subtract 1, so negative 1/2. Don't worry about negative exponent yet, we have a lot of other things to worry about first. Minus high d low. Draw a line and square what's below. Alright, so let's see what happens when we start cleaning this up. So if we start cleaning this up, we know that when we multiply numbers, but we add exponents. So this will actually be 1/2, and then x 1/2 plus negative 1/2 is 0. So that's actually not there anymore. And then we have 1 times 1/2, so now we have 1/2 x to the negative 1/2. Not too bad. Now let's distribute the negative. I'm going to do the same thing I've been doing. Put the 1/2 x to the negative 1/2 in front. So this is negative 1/2 x to the 1/2. So it's negative 1/2. And remember, we add the exponents. So 1/2 plus 1/2 is 1. And then we have negative 1/2 times negative 1. So that's positive 1/2 x to the 1/2. And then we have our line still and all that squareds on the bottom. So if we look at this, technically, the positive 1/2 x to the negative 1/2, hold on a second. Oh yeah, hold on a second. Okay, so let's look back here for just a second. If you notice, I messed up right up here for just a quick second. This was a negative 1/2 x to the negative 1/2, and I lost that negative when I was multiplying. Shame on me. So this should be negative 1/2. So this is 1/2 negative 1/2 plus positive 1/2. That should have been a 0. And then that should also be negative 1/2. So we have really x to the 0 isn't there. And x to the 0 isn't there. And then we have a 1/2 and a negative 1/2 that's not there. here we have 1/2 x to the negative 1/2 plus 1/2 x to the negative 1/2. So that's 1x to the negative 1/2. And we draw a line. We have x to the 1/2 plus 1 squared. And now, most of us don't really like those negative exponents, although that answer's technically right. We can clean it up a little bit by moving the negative to the bottom. So all I would do here is I would leave the 1 on top and then just move that x to the 1/2 on the bottom and x to the 1/2 plus 1 squared. And of course I could rewrite this, and if it was a multiple choice question, it definitely could show up as the square root of x times the square root of x plus 1 squared. And that's probably how I would expect to see that was useless. That's probably how I'd expect to see the answer, but they really could do it either way. So either of those answers are acceptable, but I would probably expect to see it like the one on the bottom with the square roots. I'll try circling it one more time for you. There you go. That was better. Alright, we're almost done. So sometimes they give it to us where they tell us the derivative of value and they tell us the different values. So if we look at this, we have u times v. So we have to ask ourselves, what is that one? And of course that one is the product rule. So I know the product rule is I keep the first one the same, do the derivative of the second one, plus I do the derivative of the first one, and I keep the second one the same. Well, they gave me all of those values. I have everything I need. I know that when x is 0, u is 5. The derivative of v is 2. The derivative of u is negative 3. And v is negative 1. So then we just do the math. We have 10 plus 3, which is 13. Hopefully that's what's back here. Now I guess I gotta move it. There it is. Alright, so then if we look at letter B is actually the quotient rule because I have division. So I just think of the quotient rule. The quotient rule says low derivative of the top minus high derivative of the bottom. Draw a line and square what's below. Well, I have all those values too. I know that v is negative 1. I know that the derivative of u is negative 3 minus u. U is 5. The derivative of v, or the derivative of the bottom, the derivative of v is 2. I draw a line and square v. So this is 3 minus 10 over 1, which we know is negative 7. Now, letter C is basically the quotient rule again, but this time they've changed up the v and the u. So that's why I like the low d high saying instead of trying to memorize the rule, because it doesn't matter the order in which they put it, you can do it. We have low. You should actually try this one. So pause me and give this one a try. You can come back and watch it if you need help. If you don't need help, just skip ahead a little bit and watch for the answer. So we have low, d high, minus high, d low. Draw a line and square what's below. So u is 5. The derivative of v is 2. Minus v is negative 1. The derivative of u is negative 3. And draw a line and square what's below. So we have 10 minus negative 1 times negative 3 is 3. 10 minus 3 over 25. So 7 over 25. Our answer there. Now D should technically be the easiest one because do you see how this isn't really the product rule. This is just a constant times a value. So if you think about just the plain function 7x, well, the derivative of 7x is 7. If you have a constant, it stays on the outside when you find the derivative. If you think about, let's say, 7x squared, the 7 stays there, you bring the 2 down and you subtract 1. So the 7 kind of chills. It's not really part of the function. It's not really part of the thing you're finding the derivative of. Constants just stay in front. So here the 7 chills, but don't forget you're finding the derivative. So you have to use the derivative of v. The 2 is another constant, so it just kind of chills. But you're finding the derivative, so it's the derivative of u. So this one's the easiest one, but the most missed one. So it's 7 times 7 times the derivative of v is 2 minus 2 times the derivative of u is negative 3. So we have 14 plus 6, which of course is 20. Okay, so here's our last problem for the day. This time they want us to find the second derivative, which probably is going to be a pain, but we'll give it a try. So the first derivative, we know we're going to have to use the quotient rule because we have a lovely quotient. So we know it's low d high. Well, the derivative of our high is 1 minus high d low. Derivative of our bottom is 1. Draw a line and square what's below. Alright, so we have, clean that up, x minus 1 minus x all over x minus 1 squared. Which, of course, the x's cancel out. So we have negative 1 over x minus 1 squared. So that's the first derivative. If we go to do the second derivative, though, we don't know how to find the derivative of this yet. We're going to have to wait for a little bit to find the derivative of that. So I'm going to multiply that out, and I know that that will be negative 1 over x squared minus 2x plus 1. So I'm going to need that in order to do the second derivative. Alright, so let's use the quotient rule again for the second derivative. So we know it's low. The derivative of 1, or negative 1, is 0. So all of that's gone. Minus high d low. So the derivative of the bottom is 2x minus 2. We draw our line and we square what's below. So here we go. I just need a little bit more space. Anything with, like I said, anything times 0 is 0, so that's gone. We have 2 negatives, so that becomes plus 1. So really 1 times anything is whatever you multiply by. So it's 2x minus 2. I lost the squared there. Over x squared minus 2x plus 1 squared. So the second derivative is that. Alright, so you should have everything you need to practice the product and quotient rule. Good luck. Have a good week.